Alright, today is going to be Unit 12, Day 1. This unit is an introduction to graphing trigonometry. And today we're going to be looking how to graph the sine and cosine functions. We're going to create a unit circle on the axis below for both positive and negative angles in radians only. Whenever you graph with trig, you're going to be using radian measure, not degrees. Okay. Now, we don't want you to really do this on your calculator because you're not going to get a very good table of values that helps you graph. But if you ever do anything with graphing on the calculator, it has to be in radian mode, just so you know. Alright, so I'm going to draw a unit circle here. And I am going to draw a unit circle here. The first unit circle I am going to label the positive radian measures. So we start at 0. Recall that 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. And if we were to label our negative angles, we're going to go 0, and remember we have to go clockwise, so this is going to be negative pi halves radians, negative pi, negative 3 pi halves, and negative 2 pi. We are going to now use these pictures to fill in the charts below. When we graph sine and cosine, the values, the points that we put on our graph to connect are the trig values that come from the quadrantal angles, the 0, the 90, the 180, 270, and 360. No matter what kind of graphing we do for sine and cosine, it always comes back to the angles around the unit circle that falls on the quadrants. Alright, so cosine. I like to start at 0 and do the positives first. So we're going to start here. Cosine of 0 radians is the same as cosine of 0 degrees, and on the unit circle that would be a 1. And then if I move up to the 90, which is pi halves, cosine is 0. Cosine of pi, which is 180, is negative 1. Cosine of 270, which is 3 pi halves, is 0. And cosine back at 360, which is 2 pi, is 1. Alright, let's do the same thing for the sine. The sine of 0 is 0. Sine of pi halves, up there at 90, is 1. Sine of pi, which is the same as 180, is 0. Sine of 3 pi halves, same as 270, is negative 1. And the sine of 2 pi is back to 0. Alright, so that was using the positive unit circle. Now let's do the negative unit circle, but we're going to go in this direction and fill the table out now backwards. So here's my 0. Okay, I already answered that. The cosine at 0 is 1. So when I'm coming down here, the cosine at negative pi halves is 0. Cosine at negative pi is negative 1. Cosine at negative 3 pi halves is 0. And the cosine at negative 2 pi is 1. Remember, we're on a unit circle, so it's either zeros or ones. Same thing for the sine. Sine of negative 2 pi halves is negative 1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is positive 1. And sine of negative 2 pi is 0. If you look at that chart, you should see that there is a pattern. Every other one's going to be a 0, and then the ones and negative ones alternate. Okay, and you're going to see this pattern show up a lot. Alright, so using the table above, graph y equals sine x from negative 2 pi to positive 2 pi. Now, here's my 0. Now if you look, I have 4 values past the 0, which gets me all the way back around, and I got 4 numbers the other side of 0. So I'm going to skip a block and go every other one. So this is going to be pi halves. This is going to be 1 pi. This is going to be 3 pi over 2. And this is going to be 2 pi. And I'm going to do the same thing on the other side. Negative pi halves, negative pi. Negative 3 pi halves, negative 2 pi. And then I'm going to go up here all the way to the top and say this is 1 and this is -1. Now we're just going to plot the points. So cosine, which one am I doing? I'm doing the sine first. All right, so we're plotting the sine. Sine of 0 is 0. Pi halves goes up to 1. Then it comes back down to 0. 3 pi halves is -1. 2 pi is 0. Now sine's kind of curvy, kind of like U's. Get mountains and troughs. All right, negative pi halves is down here at -1. By the way, before I graph any more, what you're looking at right now on the positive side is what we call one full cycle of sine. So a hill and a trough together make one full cycle. All right, so I'm going to keep graphing. Sine of negative pi is 0. Negative 3 pi halves is 1. Negative 2 pi is 0. And it's going to be curvy. So it just kind of repeats itself. So what I'm looking at now is 2 full cycles of pi, of sine. One on the negative side, one on the positive side. All right, so the domain is the x values, which is -2 pi to 2 pi, because that's what they told me to graph. It is very common that they'll give you that, or they'll say graph 1 full cycle or 2 full cycles, but they never just say graph, so we don't end up putting arrows on these ones. Range, that's the y values, low to high, -1 to 1. Actually, these should be square brackets. Midline. The midline is the line, the horizontal line, through the center. Better way to say that is halfway between the highest and lowest points. Highest and lowest points. So if our highest point is 1 and our lowest point is -1, then 0 is right in the middle of those. So our midline is y equals 0. Later on, we are going to be learning how the midline is important to word problems. Radio waves, ocean waves, those kind of things, they follow a trigonometric curve, and that midline is a very important piece of those real life problems. All right, so we're going to use the table above again, and we are going to graph the cosine. So again, I have to label pi halves, pi, 3 pi halves, 2 pi, negative pi halves, negative pi, negative 3 pi halves, negative 2 pi, and again I'm going to do 1 and 1. So this is 1, and this is -1. All right, cosine of 0 starts at 1, pi halves is 0, then we go -1, 0, back up to 1, and a cosine to me kind of looks like a cursive V. So it's not quite as wide and fat as a sine, but it can't be like a straight V like that, because that's an absolute value graph, and you definitely will get marked off for that. This right now on the positive side is one full cycle of cosine. So it kind of looks like a V. It starts in the air and ends in the air. So cosine is a V, sine is a hill and a trough. All right, graphing the other side. Plot the points, and you get a second V on this side, so now it kind of looks like a W. That's 2 cycles of cosine. Again, domain is -2 pi to 2 pi because they told us to graph those x values. Range, low to high, -1 to 1 again. So midline, which is halfway between 1 and -1, is going to be y equals 0. You've done transformations of functions already in Algebra 2, and yes, they will throw some transformations of trig functions at you as well. So that midline will change when we start getting into transformations. All right, how long does it take for both the sine and the cosine graphs to complete one cycle before they start to repeat themselves? 2 pi. So when we started graphing at 0 and we got to 2 pi, that was one full cycle. And if we graphed past 2 pi, we would just start the same pattern all over again. Okay, so the period is what we call that. The period is how long it takes to complete one cycle. Generally, it takes 2 pi we will eventually mess with that. But a standard cosine graph, a standard sine graph, the period will be 2 pi. That's how long to get one cycle. All right, so amplitude. Amplitude is how high or low, let's see, how high above the midline the graph goes. Amplitude is always positive. So it tells you how high above the midline, but then it's also going to tell you how far below the midline it's going to go, since the midline's halfway through. So amplitude is how high above and below the midline your graph is going to go. Your amplitude is called A, and it will be the number that touches your trig function in the front. Okay. Now again, when graphing a trig in a calculator, you must be in radian mode. Make sure you go change the mode on your calculator right now, because I'm going to ask you to pause the video in a minute and use your graphing calculator. Graph y equals cosine x first, and go hit graph and look at it. You're going to see a whole bunch of little v's fill up your screen. And then I want you to graph each one of these separately. So leave the y equals cosine x in y1, and then type in y equals 3 cosine x into y2 and see what the difference is. Okay, see what the second graph does compared to your cosine graph. Then I want you to erase that one and then put the negative 3 cosine x into y2 and see what happens. And then erase that one and put this one in and see what happens. So one at a time, I want you to compare these 4 graphs to y equals cosine graph in your graphing calculator. So hit pause now, go do that, and then resume this video. All right, so what you should have found out is that the coefficient in front controls the height that the cosine curve rises and falls above the x-axis, which right now the x-axis is the midline because we're not messing with it yet. Okay, this is a vertical stretch like you learned in transformations. Its absolute value is given the name amplitude. In terms of sound waves, it indicates the volume of your sound. How did the negative with the amplitude in front of the function affect the graph? Well, you should have seen it on your calculator, or if you remember back from transformation, it flips the function upside down. So once again, amplitude is how high above the midline your graph goes. Okay. All right, so we're going to do a little graphing. We're going to play around with the amplitudes. Okay. And another thing we're going to do is we're going to play around with the domain. So this one doesn't say graph from negative pi to 2 pi. Or sorry, it doesn't say negative 2 pi to 2 pi. It says start at negative pi only. Well, for today, we are not going to change how we label our x-axis. So on the 2 graphs we've already done, we labeled them pi halves, pi, 3 pi halves, and 2 pi. That's going to stay the same. And it said go all the way to positive 2 pi. Now on the left side, we've got negative pi halves and then negative pi, which is where they want me to start. So I'm not going to label any more than that. So the first one wants us to regraph this again. So y equals sine of x. One thing to keep in mind is that a sine graph will always start at 0 because the sine of 0 is 0. And then after that, if you can remember the pattern, it won't take you very long to graph these at all, because a regular sine graph with a positive amplitude has a hill and then a trough. The amplitude on this one is 1. So I am going to call this 1. I'll call that 2 for the next graph. Negative 1, negative 2. So I know that I need a hill first. So on my next spot, which is pi halves, I go up to the 1. And then I know I go back to 0. And then I fall to negative 1, and I go back to 0. because that's the pattern that a sine wave is going to have. So I can just plot them real quick and go. I also know that this pattern has to continue. So when I go on the negative side, okay, I have a hill at pi halves. 0 is 0, so I got to go down and make a trough at the -1, and then I go back to 0. And I flip her around, and I'm going to label this y equals sine x. That's in purple. Now I have the benefit of changing colors, so you'll have to maybe change colored pencils or pens or something at home. The midline, again, our highest was 1, our lowest was -1, so y equals 0 is in the middle. Next one has an amplitude of 2. So if you look at the equation, this says take 2 and multiply it by the sine of x. Okay, so the sine of 0 is 0. 0 times 2 is still 0, so I'm still starting on the origin. Pi halves is like 90 degrees. The sine of 90 is 1, and if I multiply it to 2, I get a 2. Sine of pi, which is 180, is 0. 0 times 2 is still 0. Sine of 270, the 3 pi over 2, is -1. Well, -1 times 2 is -2. Sine of 360 is 0. So we still have the same hill and trough pattern exactly, except that instead of going from 1 and -1, we went to 2 and -2. All it did was stretch it. And my midline is still y equals 0 because I'm halfway between 2 and -2. All right, but I got to graph the other part. So now I got to go down to -2 and back to 0. So my blue graph is 2 sine x. Okay. And the last one, hopefully you can see it, is in green. This time my amplitude's a half. So if you can take the pattern from the blue graph, all we did was stretch it up to 2 instead of going to 1. This time we're going to go to a half instead of going to 1. Other than that, the graph's exactly the same. So sine of 0 is 0. We're starting on the 0. And my next spot, instead of going up to 1, I'm only going to a half. Back to 0, down to -half, back to 0. So I get a squatty little, almost flat sine curve. And then continue the pattern on the negative side. So that goes down to -half, and that goes to 0. Okay, so y equals half sine x. So the amplitude just plays with the height, how tall your hills get and how low your troughs get. Okay. All right, we're going to do the same thing for the cosine graphs. So let me put my labels back. There's 1. And we're going to count by pi halves. And pi. 3 pi halves. And 2 pi. And this time it says graph from 0 to 2 pi only. So we only have to graph the positive side. Alright, so my first graph is y equals cosine x. Alright, so remember cosine x is a v. Cosine of 0 is 1. And if you can remember that the pattern of cosine makes a v, you really don't have to think too hard on how to get your next points. You're at 1, you go to 0, then you go down to -1, then you go back to 0, and you go back up to +1. It's a pattern. Every time the cosine's going to look like a v. And kind of make it a little bit of a cursive v as much as you can. And that's y equals cosine x. Alright, next one. The amplitude's going to go up to 2. As you saw on the sine graph, that just means instead of going to 1, you're going to go to 2 instead. So instead of starting at 1, we're going to start at 2 and make a v. 2 to 0 to -2 to 0 to +2. Make a cursive type v. And there's your cosine for 2x. Okay. And the last one has an amplitude of 1/2. So instead of going as high as 1, we're going to start at a half instead. So cosine of 0 is going to start at the half. 0, negative half, 0, positive half. And there's your 3 cosines graphs. And what's the midline for all 3 of them? Y equals 0. Okay, that'll change when we get into shifting, but that's another lesson. All right, I know I probably plotted those really fast. I'm sure you probably had to stop the video a few times to catch up, but graphing, sine is hill and trough with a pattern. Cosine is a V with a pattern. Learn the pattern and graphing gets a whole lot faster. Okay, day 1 is the homework that goes with this lesson. Good luck.